This video will present solutions to the 2018 VCE Mathematical Methods Written Examination 2, Section B, Question 4. Question 4. Part A concerns the resting heart rate of adults in Mathland, which we are told is normally distributed with a mean of 68 beats per minute and a standard deviation of 8 beats per minute. And we are asked to calculate the probability that a randomly selected adult has a resting heart rate between 60 and 90 beats per minute. This can be calculated using their normal distribution. Returning a probability of 0.838. Part B, Part 1. The probability of H given S is equal to the probability of H intersection S divided by the probability of S. The probability of H intersection S is a probability that a randomly chosen adult both plays sports regularly and has a low heart rate, and this probability is equal to 0.09. The probability of a randomly chosen adult playing sport is 29%. Hence our calculation is 0.09 divided by 0.29. To 3 decimal places, this answer is equal to 0.310. B Part 2. We are now asked whether the events H and S are independent. We have calculated that the probability of H given S is equal to 0.310. And we are told that the probability of H is equal to 0.1587. This tells us that the probability of H given S is not the same as the probability of H, and therefore these are not independent events. Part C, Part 1. This concerns the slow heart rate of random samples of 16 Mathland adults. This can be modelled by a distribution X, which is binomial in nature, with n equals 16 and p equals 0.1587. The probability that x is exactly 1 can be calculated on our class pad. And this probability is equal to 0.190 to 3 decimal places. Part C, Part 2. We are introduced to the variable p hat, where p hat is a proportion drawn from a sample of 16, and hence is equal to x divided by 16. The question of p hat being greater than 0.1 becomes a question that x divided by 16 is greater than 0.1, or in other words, x is greater than 1.6, and given its discrete nature, this tells us that we need to consider x greater than or equal to 2. And this calculation can be performed on our class pad. Giving us a value to 3 decimal places of 0.747. Part C, Part 3. We are now considering samples of size n, and so our p hat variable will be equal to x divided by n. Hence we are interested in x on n being greater than 1 on n, which implies that x is greater than 1, and as x is a discrete random variable, this means we are interested in x greater than or equal to 2. So we have a discrete random variable x, modeled by a binomial distribution with sample size n and probability 0.1587, and we are interested in the probability that x is greater than or equal to 2 being greater than 0.99. Once again, this is a binomial cumulative calculation. The probability is between 2 and sample size, which at this stage is x. Given the sample size x, and the probability of success 0.1587. Now, whilst this cannot be calculated directly in the main menu, it is this structure that we are interested in. I'm going to copy this and paste it into a table to investigate the values of x that satisfy the criteria greater than 0.99. I'm going to look at a table of values where x starts at 16. As we know, the probability when n equals 16 was 0.747, and my table is going to extend to n equals 100, and I'm looking for values where the probability exceeds 0.99. Looking at this table of values, we are interested in when the probability first exceeds 0.99. We can see that this occurs for the value n equals 39, and hence this is our answer. Part D, Part 1. The sample proportion p hat is equal to the average of the bounds of the confidence interval, i.e. 0.102 plus 0.145 divided by 2. Giving us a p hat value of 0.1235. Part D, Part 2. Explain why this confidence interval suggests that the proportion in Statsville is different from the proportion in Mathsland. Well, the Mathsland proportion is 0.1587. This value lies outside the Statsville confidence interval of 0.102 to 0.145, and this implies that the two proportions are different. Part E. This question now concerns itself with a probability density function m. I'm going to define this function on my class pad. With this having been done, I can now compute the expected value of this function. This is equal to 44.6 minutes. Now we are interested in the proportion of students who take less than 15 minutes to get to the top of the hill, as these are categorised as elite. This can also be calculated on my class pad. This probability is equal to 0.0266. The proportion of MSc students that are Year 12 and elite is 1/7 multiplied by 0.05, which is equal to 0.007143. As overall 0.0266 of MSc is elite, then the proportion of MSc that is elite and not Year 12 is 0.0266 minus 0.007143, which is equal to 0.0195. With this information, we can find the probability that a randomly selected non-Year 12 student is categorised as elite. This will be equal to the probability that a non-Year 12 student is selected and they are elite, divided by the probability that a non-Year 12 student is selected. This is equal to 0.0195, the value calculated earlier, divided by the proportion of non-Year 12s, which is 6/7. And this is equal to 0.02275, which is equal to 0.0228 to 4 decimal places.